Hello and welcome to my YouTube channel. This is Dramani Online Maths. Please, if you have not subscribed, please subscribe to support my channel. Thank you very much. We are now going to look at the application of differentiation. Where and when can we apply our differentiations? Is that okay? So we have evaluating gradients at a point. But before I look at that, I want to ask you this. If you remember, I told you that differentiation at a point is the same as what? Finding a gradient. So all the dy dx you have been finding, if a point is given like x equals 1, x equals 2, x equals 3 is given, when you substitute there, then your dy dx becomes your, your gradient. Is that okay? Yes. So that's what we are talking about here. I think I've left something out here. Here's supposed to be 1, 1. Okay. So let's look at how we can do this. So the simple thing that you are going to do here is that if you want to find a gradient, the simple thing that you do here is very simple. What you do first is that you differentiate it. Then after that, the point given to you. So here they are saying that we have to find the gradient of the following curves: y equals x key plus 2x plus 4 at x equals 2. So after you are done differentiating, you substitute the value into it. The answer that you get becomes your gradient. Already I've explained that to you, that your dy dx is the same as the gradient at a point. Okay, so let's start. So this is the question given. So first we need to differentiate this. Okay, so I have dy dx equals 3x squared plus, you differentiate 2x, you get 2. If you differentiate 4, you get 0. Is that okay? Now they are saying that at x equals what? 2, meaning that dy dx is equals to 3. Wherever you see x, you put 2 there, so squared plus 2. So dy dx will be equal, 2 squared is 4. 4 3 is what? 12. You have 12 plus 2. So my dy dx equals 14. But dy dx is equals to what? M. Okay, is equals to the gradient. But we abbreviate it as what? M. Is that okay? So therefore our gradient is equals to what? 14. Is that okay? It's nothing difficult. Once they give you the function, they give you the point, and you have to find the gradient, all you need to do is differentiate it. After that, you substitute the point given to you in wherever you see x, then you are good to go. And we are saying that gradient at a point, differentiation at a point is the gradient. So dy dx is equals to the gradient. Thank you very much. Let's move to the next example. Okay, so now let's look at the second example. X squared plus 2xy plus y squared equals 0. Though I haven't started yet, but you can testify that this is what? Implicit differentiation. So first, let me differentiate x squared. This gives us 2x, 2 bracket open. If I differentiate this, I'm going to have x dy dx plus y plus 2y dy dx equals 0. Is that okay? I hope you all know why we had this. I've already explained it. What you do here is that you hold the x, then differentiate y. If you differentiate y, that will give you dy dx times the x. Then after that, plus, you come and hold the y, you differentiate x, you get 1. 1 times y is y. So that's how you do. That's product rule. You can also use a formula. So here I have my 2x plus 2x dy dx plus 2y. I'm just opening the brackets. Plus 2y dy dx equals 0. Is that okay? So for this way, you are going to have this and this. I can group it together to have 2x dy dx plus 2y dy dx equals, so this and this additive inverse of it, when you bring it to, you have negative 2x negative 2y. So if you divide through by the 2 it will go away, leaving x plus y dy dx. Is that okay? Equals negative out x plus y. Is that okay? So if you divide here by x plus y, here by x plus y, means that my dy dx equals to negative x plus y over x plus y. Now, for this case, okay, the point was given as what? 1, 1. Means that x is 1, y is 1. So dy dx is equals to 1 plus 1 over 1 plus 1, which will give you, in fact, here is because I just want to exploit. If not, I don't even need to substitute the points, because if x plus y can go into x plus y one time, 1 times negative will be negative 1. It's the same thing. 1 plus 1 is 2. 1 plus 1 is 2. 2 can go into 2, 1, leaving the negative. So here the answer is for negative 1. So we can conclude that our gradient is equal to negative what? 1. Is that okay? Yes. Now, let me do just one of them. I will do the I. Then I will leave. Oh, look at what I've done here. The x equals, here was x equals 1, and here is supposed to be 1, 1. X equals 1. So now here, I'm going to do this one, and I'll leave the IV and the V. You do it, and you can leave it in the comment section, or if you have my personal contact, you text me, or you can go to my bio there, you see my contact there. Okay. Okay, now let's look at the third example. F at x equals x bracket open 3 minus 2x all squared. Okay. Now, what happened here is very simple. Here, this is a product rule and also a function in a function. That's the chain rule. But you can, for maybe it will become, so I can just look at it and differentiate it. Okay. But maybe to you, you will suffer before doing this. So it's a combination of a chain rule and a product rule. So if you think you will suffer with it, you can decide to expand it, because 3 minus 2x all squared is easy to expand. Is that okay? Good. And also this f at x here is the same as y. So you can say that let y to be equal to f at x. Or you can decide to maintain this. Is that okay? So if you maintain this, then you make it f prime at x. That's first derivative. Okay. So here I'm going to have f prime at x like this. If you want to use the f at x instead of dy dx, is the same thing. But before I do that, let me expand this first. So let me maintain my x. So if I'm expanding, this will give me 9. You know what to do. Let me write, because some of you might be confused about what I'm doing. 3 minus 2x. So this is what I'm doing. So f at x equals, now you open the bracket. 3 times 3 is 9. 3 times negative 2 is negative 6x. Negative 2x times 3, that will also be negative 6x. So here gives us negative 12x. Is that okay? Then the last one will give us positive 4x squared. Good. So you keep on expanding. X times 9 is 9. X times this will be negative 12 x squared. X times 4 would be 4 x cubed. So I'm done expanding. Okay, so I have to differentiate. So f prime at x is equals to, if you differentiate 9x, what you get is 9. If you differentiate 12x squared, you get negative 24x. If you differentiate x cubed, 4x cubed, you get 3 times 4 is 12, then x squared. Is that okay? For the differentiation, I've already explained to you in the previous video. So if you know you have not watched that one, go and watch and understand how we differentiate before you come here. Okay. So now you are saying that at x equals 1. So at x equals 1, that's the meaning. So f prime at 1 will be 9 minus 24 multiplied by 1 plus 12 multiplied by 1. So f prime at 1 is equals to this 9 plus 12 is going to give us 21, right? Minus 24. So f prime at 1 is going to give us negative 3. So therefore, my gradient is what? Negative 3. So that's negative slope. Okay. Please, another name for gradient is also what? A slope. Now, try your hand on the IV and that of the what? The VV. I mean the V. The IV and the V. Try your hands on them. Thank you very much for watching. Try to subscribe and share for me. Thank you.